2 dice are rolled and the sum of the dice determines if you win the game. Use the dice chart to determine your chances of winning and find the expected value. To win $25, that's if you roll an 11. You win $5 if you roll any total of 5 or less. So when you look at this chart here, for example, this 5 right here represents getting a 3 on the first dice and a 2 on the second dice. This 5 right here is I get a 2 on the first and a 3 on the second. This 5 right here is getting a 1 on the first dice and a 4 on the second. So this is the way you want to read this chart. Now, to win $25, you need to roll a sum of 11. When you look at this chart, there's 2 ways for that to happen. You could get this 11 here, or you could get this 11 here. That's 2 out of 36 possibilities. So you take 2 divided by 36, and then the question says to round to 4 places. So you get a 0.0556 chance when we round it to 4 places of winning $25. Now to win $5, you have to get a total of 5 or less. So any number that is 5 or less is going to count. So we have this whole diagonal here, 1, 2, 3, 4, then 5, 6, 7, 8, 9, 10. So there are 10 ways to get a 5 or less. So when I take 10 and I divide by 36, that's going to give me 0.2778 when I round to 4 places. Now, because this is a probability distribution, all the other ways, right, that are left in this chart that we haven't counted yet is going to be what's left over down here. So this should total, the probabilities should total to 1. So if I take 0.0556 and I add it to 0.2778 and I subtract that from 1, what's left over is going to be winning nothing. So that's 0.6666. The other way you could look at it is that if you win 0, that wouldn't be getting an 11, and that wouldn't be getting a 5 or 6. Or sorry, that wouldn't be getting a 5 or less. So it would be all the 6s, all the 7s, all the 8s, all the 9s, all the 10s, skip the 11s because we already counted that one, and the 12s. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So that would be 24 out of 36. Which is 0.6666 repeating. So actually, we should probably round this up to 7. Okay, now, what is the expected value of the game? The expected value of the game is when you take 25 and you multiply it by the probability. Then you take 5, you multiply it by the corresponding probability. Then you take 0 and you multiply it by the corresponding probability, and then you add them all up. So I'm going to take 0.0556 and multiply it by 25. Then I'm going to take 5 and multiply it by 0.2778. And then I'm going to take 0 times this 0.6667. That's going to give me 0, so I don't have to worry about that one. And then I add everything up. So I'm going to take 1.39 and add it to 1.389. And I'm going to get 2.779. So that's the expected value. Now, if you paid $3 for this game, would it be a fair game? So the question when it says for a fair game, you want to look to see if either the expected value is 0. You want to look to see that the chances of winning are the same as chances of losing. Since the expected value here is 2.779 and you're paying $3, there isn't really a break even here. So I would say that this is not a fair game. If you played this game for a long time, would you make money or lose money? In this case, we would make money because the expected value came out to be positive, which means in the long run, after I play this game many times, in the long run, I'm going to make an average of $2, and if we round to two places, $2.78 per game.